Good morning, everyone. Thank you for coming for the morning session. My name is Alok Tongaonkar. I'm a senior member of technical staff in the CTO's office at Narus. Today, I'm going to talk about challenges in network application identification. This is related to the research that we are doing for traffic classification, along with my colleagues Keralapura and Antonio Nucci. Before I start discussing the problem of traffic classification, I would like to tell you something about Narus and why we are interested in this problem. Narus is a traffic analytics company. We develop software for real-time monitoring of network traffic and analyzing the data. The CTO team at Narus comprises of 15 research analysts and engineers. Our goal is to invent and innovate. What I mean by invent is that we look at research problems and try to come up with novel solutions for the problems. By innovate, I mean we try to turn these novel solutions into product-like prototypes that can be used in the commercial world. We conduct a Narus Research Fellows program that allows us to collaborate with universities on interesting problems. This is a year-long program that runs from January to December. As part of this program, this year, we are collaborating with 10 faculty members and 20 students on interesting research problems. An important aspect of our job is to write proposals to obtain funding from sources like our parent company, Boeing, and external sources like DARPA and DHS. Lately, we have been doing a lot of research in exciting areas such as cybersecurity, mobile security, and social network analysis. But given that our core expertise is in traffic classification, it still remains one of the major areas of research for our group. Traffic classification is a very well-studied research problem. Internet service providers and network operators have always been interested in finding out what applications are running in their networks. This information is useful for many network management applications like traffic engineering, network planning, and billing. It is also crucial for many security applications like intrusion detection systems and application-level firewalls. Early traffic classification systems were based on port-based traffic classification. What this means is that those schemes relied on L4 protocols and ports to identify the applications. So for example, all UDP traffic going on port 53 would be classified as DNS traffic. The advantage of the scheme is that it is simple, easy to implement, and has high classification can be performed at high speed. The problem with this approach is that it does not work in the way networks are being used now, mainly because more and more protocols are using random ports for communicating. For example, BitTorrent clients can communicate over any user-configured port. Also, this scheme fails to identify tunneled applications such as SMTP traffic running inside HTTP session. The failure of port-based traffic classification scheme sparked a lot of interest in the research community in flow features-based traffic classification. These data mining-based techniques analyze L4 headers to identify unique properties that can be used to identify applications. For example, if you want to identify some features for BitTorrent protocol, we can look at the packets that are generated by BitTorrent and identify features like packet interval time, packet sizes, or other header information like TCP flags used to identify BitTorrent protocol. These features may not always be useful to identify all protocols. For example, if we consider BitTorrent and POP3S protocol, and we consider the packet sizes of the first 6 packets, and we consider the packet sizes from different flows, we can see that for BitTorrent, maybe the packet sizes of the first and the second packet may be useful for identifying the protocol. But for POP3, we may be able to use the packet sizes of all the first 6 packets to identify the protocol. An interesting thing to note here is that these kind of techniques can be used to identify even encrypted traffic. In spite of the fact that these techniques can be used to identify encrypted traffic, and the classification speed is very high. These techniques never gained much traction in the commercial world. The main reason for this is that they have low accuracy. Commercial world in recent years have turned to deep packet inspection to obtain the accurate traffic classification. Deep packet inspection-based systems look at packet payloads and try to match patterns within the payload. So for example, if we have some packet payload which contains the keyword LO, it may be classified as belonging to the SMTP traffic. Similarly, if LO occurs in the traffic but at a different location, different offset, it may still be classified as SMTP. On the other hand, a payload which contains HTTP would most likely be identified as HTTP. Deep packet inspection-based systems have high accuracy. The problem with deep packet inspection is that the performance of classification, that is matching, could be very poor. But this area has received a lot of attention in the research community. So I'm not going to talk about this problem in this talk. On the other hand, signature development for DPI-based system is still in dark ages. What we have right now in commercial world is that most of the DPI-based systems rely on manual generation of signatures. This worked well a few years ago, where tedious process of understanding specification or reverse engineering the protocols from application binaries or network traces could work. But in recent years, the way we use networks has changed tremendously. What this means is that the manual process of extracting signatures is no longer scalable. So let us see what has changed in recent years that affects the network operators. A few years ago, network operators could concentrate on the layer 7 protocol, top 50 or 100 layers 7 protocols, and identifying those protocols meant that they could cover most of the traffic. But in recent years, we see that a lot of applications are tunneled inside layer 7 protocols or applications. With the increase in popularity of web platforms like Facebook, this means that there are more and more applications which are running over other applications. So what this means for network operators is that it's not sufficient for them to identify the protocol, just the protocol. They need to be able to identify the applications running within those protocols. So for example, it's not good enough for the operators to know that there is HTTP traffic. They need to know whether there is Angry Birds running inside Facebook, running inside HTTP. So the ease of development of applications on this platform means that there are a lot of new applications which are coming up. And as Engin mentioned in his talk, these new applications could form the new vectors for attacks. What this means is that there is a growing disparity between what the network operators get from the current systems and what they really want to have. So what they get is coarse-grained classification with a lot of unknown flows. What they really want to have is fine-grained classification, where they can say that the flow is not just SMTP, but whether it's going to Hotmail, whether it's Yahoo Mail, or whether it's Google Mail. Also, they want to have the number of unknown flows to be very low. Another interest, yeah?
Rick Farrow. So this sounds really good, but isn't it easy just to hide one application within another? It's not just, no, I don't mean like tunneling. I'm thinking more, and my brain's not working yet. Like when you have an image, and inside the image you have encrypted some data. In the same way, you make it look like one protocol, but really you're using a little, you're just flipping bits somewhere and then use that for your communication. Steganography, thank you. Yes, please.
Yeah. More generally, it'd be helpful, I think, to elaborate a threat model.
Yeah. So what we are trying to target here is trying to go after applications which are running inside other applications. So in previous years, people were concerned just with knowing whether the traffic is HTTP, SMTP. But what we need to know now is whether there is Twitter traffic inside the HTTP. As Engin mentioned, that Twitter traffic might contain attacks. So how do you know whether your traffic contains Twitter application traffic, right? So that is the threat model that we are looking at. Also, to address your question, it is true that applications can hide within other applications, and that is exactly the problem that we are looking at. That is a problem for the network operators. So here I'm not trying to tell you what are the solutions, how can we find those applications. What I'm trying to tell you is that this is a real problem, that we really need to understand what is going on. Network operators need to know, not just at the level of layer 7 protocols, but what is inside those protocols.
Niels Provos, but just to be clear, you are not actually trying to identify traffic where people intentionally try to hide from traffic classification.
So that is also something that may be possible. But at this level, first we need to be able to identify at least the benign traffic, where we just have, say, Angry Birds going over Facebook. We need to be able to identify that. Sure. Once we are able to identify that, then we can think about how we can overcome problems where people are trying to obfuscate their intentions.
Okay. Well, Neil just stole my question. That was also my question. So you're assuming that it's not an adversarial setting?
It's not an adversarial setting. That presently, network operators just need to be able to identify, and that itself is a challenging problem. So first we need to solve that problem before we can start thinking about how we can overcome adversarial situations. So this problem becomes even worse when we think about the mobile networks. So if you think about the recent trends that affect network operators, there has been an explosive growth in the number of mobile applications in recent years, both on Apple Store and in Android market. We can see the number of apps that have grown. But there is nothing that helps the network operators identify these applications. This, combined with the fact that more and more users are bringing their own devices inside enterprise networks, means that in future, these devices and apps could become the entry point for attacking the enterprise networks. People are storing more and more enterprise data on their devices, so the information might leak out from these devices, from these apps. So what this means is that enterprise operators are being increasingly asked to gain deeper controls on the apps which are running within their networks. But sadly, the reality of the situation is currently network operators have little or almost no visibility into what applications are running in their networks. What all these factors point to is that the current way of generating signatures, which is manual, is not going to scale, because we are no longer dealing with hundreds of applications. We are dealing with thousands of applications, and the number of applications is increasing every day. So, yeah, Fabian, you have a question?
So quickly, from Narus's point of view, can you give any indication of what percentage of the traffic that you guys observe that you have no visibility into? That is, it's either compressed traffic, encrypted traffic, something that you have, what percentage from your point of view is that you just have no visibility into, so the DPIs can do their job anyway? Okay.
So we used an open source tool called tstat for analyzing some data from cellular service provider. tstat, which has signatures for a lot of applications. And we observed that it was able to identify only 70% of the traffic. And of the 70% that it labeled, most of it labeled as HTTP, which, as we see, is no longer enough. Just saying that some traffic is HTTP is not good enough. We want to know what traffic is running inside HTTP, because if you consider the mobile apps, most of the traffic there is HTTP. So just knowing whether it's HTTP is not good enough. Also, if we looked at data from another cellular provider, and most of it is Android traffic, we have no visibility into that. All of the traffic just shows up as HTTP there. Does that answer your question?
But that you have visibility into it, right? It's clear text, so you can go, the DPIs can go in and do a deeper inspection.
True, but right now there are no DPI systems in the market which have signatures for all of these applications. So DPI systems stop at the point where they identify HTTP, and they stop after that. So if you look at the Android market, it has 400,000 apps. There is nothing that identifies those apps from network traffic.
But it's not fundamental that DPI has to stop at layer 7.
There is no reason that it has to stop. It's just that if you have to create signatures manually, it's a tedious task. and you are fighting a losing battle because the number of apps that are getting developed is where the rate at which they are getting developed is very high.
I hear you on that, and I agree. I wasn't clear, and maybe I just didn't hear correctly, about the original question was just how much of it is it a losing game because you have no visibility? It's, it's over SSL.
So I don't have the figures with me right now, but here we are not even talking just about the encrypted traffic. This is clear text traffic. So even encrypted traffic is another problem, and that may be possible to handle using flow feature-based kind of techniques. So a major chunk of traffic is encrypted, then the other half, which is clear text. Even there, we are failing to reach our goals. So
can you give us some numbers? So from your point of view, how much of the traffic is encrypted where you can't do any deeper inspection?
So it depends upon the data set. So for the data that we were using from the cellular provider, because it was all mobile traffic, most of it was unencrypted. So we noticed one thing, that for mobile applications typically, the applications use just the SSL or encrypted part at the initial login part, and after that they use clear text flows. Any other questions? Okay. So the key takeaway point here is that the key challenge in making application signature generation scalable is to automate the process. But there are a lot of challenges in automating this process. And the key challenge is how can we generate signatures for zero-day applications? What I mean by zero-day applications is applications for which we have no a priori knowledge in the form of network traces which belong to that application or the access to the application binary. The main...
Is it such a wise idea to be calling these signatures for applications that you have no a priori knowledge for zero-day applications? That kind of not really appropriate.
Sorry? Yeah.
I can see why you'd like it, Vern. It kind of gives the connotation that there's something malicious with the application.
Oh, okay. So this is not related to maliciousness of the apps. It's more to do with the fact that we don't have any information about it, and we want to identify the apps as soon as we start seeing their traces in the real-world traffic. So there are a lot of related problems to this key challenge. The main problem that we have is how can we effectively identify what we don't know? So given real-world traffic, how do we know what is the traffic which belongs to a particular application? So if we are trying to learn signatures from network traffic, we need to be able to form flow sets or training set for that particular application. So the main problem there is how do we ensure that the impact of noise is minimized? Also, how do we, sorry, is there a question? Okay. Also, how do we ensure that the flow sets that we are creating for the training purposes has enough diversity of flows so that we can capture different modes of application. At the same time, it is representative of the application. Another crucial problem that we have to look at is how do we handle applications that are run over TCP versus those that are run over UDP. Another important question that we need to handle is how do we handle applications that are text-based versus applications that are binary-based or run in mixed mode. Some other challenges in making automatic signature generation practical is that currently, if you see, most of the systems run in a mode where the signature are developed once and then deployed at different locations and used all the time. Is this a correct approach? Maybe or maybe not. It depends. So one of the factors that we have to consider here is that different applications may exhibit different behavior over time. So this may be because of different implementations that are used for those applications, or it may be because the application has different modes which show up over different times. So for example, an application might have two commands, one of which shows up in the training set in the first day, and the other one shows up after a few weeks. An alternative approach could be learn the application signatures continuously. The problem with this approach is how do we avoid relearning what we have learned? Put in other words, if we have learned a signature and we learn a signature later, how do we remove the redundancy between the signatures? Another interesting problem that we have to look at is how do we handle conflicts? So for example, if a DPI system which handles tunneled application returns two app labels, how do we know that it is one application tunneled inside another application? For example, if a DPI system returns BitTorrent and HTTP labels, it may be that it is BitTorrent carried inside HTTP, or it may be that the DPI has misclassified HTTP traffic as BitTorrent. So that is another interesting problem. So I'm not going to go into the details of what has been tried for automatic signature generation in the academia, but I want to note here that a lot of attention has gone into automatic signature extraction in the academia. But all of these techniques fall short when you are trying to identify applications or zero-day applications in the real world. Finally, I would like to conclude that traffic classification is a very interesting research area, especially the problem about automatic flow or signature extraction. There are a lot of challenges here which can help us to innovate, which have a lot of scope for innovation and invention. Here again, by invention, we mean that can we build new signature generation schemes that can handle these new platforms like web platforms or mobile systems. And we also have a lot of scope for doing a lot of innovation, that is taking these ideas from academia, which are being developed, and then try to develop practical systems from those. And finally, I would like to thank our collaborators at Narus, Politecnico, Torino, UC Riverside, UC Santa Barbara, and UC Berkeley, who have been helping us on doing research in this area. Any questions?
So,
Thank you.
Thank you.
Thanks for the talk. That was really stimulating, and I agree. I think this is an important area and a hard area. I'm wondering what you think about the potential for crowdsourcing as a way to develop recognizers for different
Sorry,
apps.
I couldn't.
Crowdsourcing.
Crowdsourcing.
Yeah, and so let me elaborate just a little.
Yep.
So, I'm struck at how last time I looked, which was a while ago, Wireshark had 600, 800 parsers in it,
Right.
All seemingly written by different people, and that's pretty impressive. You're right that there are thousands, not hundreds, but possibly there's a way to think about tools to help such crowdsourcing. And the last part of my comment would be, it does seem really important to distinguish network operators wanting to know what traffic is so they can make policy and traffic engineering decisions from, say, intrusion prevention, where you really do need to understand the semantics.
Yeah. So as for your first comment, I think it's a really interesting suggestion that crowdsourcing can be used to generate signatures. The question with that is, in commercial systems, do you trust signatures which are developed by other people? So that is a question about how much trust network enterprises would have over signatures developed by people in public. And you could have people developing signatures which fail to detect malicious apps.
Yeah, though I suspect most operators would take something over nothing.
Yes, definitely. So that is a very good suggestion. So, sorry, what was the second?
It was the observation that there really are these two different
Right.
uses, and one of them requires essentially parsing and semantics, and the other doesn't necessarily.
Right. So I agree completely with you on that comment as well. So the requirements that are there for security are very different from what is there for, say, network planning. So a network operator might just be interested in knowing how much bandwidth is being consumed by, say, some applications in their network. So this is a very different application. Here they can afford to lose a few flows. As long as they get a fair picture of what applications are running, they are good. But for security, you need to be able to identify each and every flow which is passing through. Intrusion prevention is an even harder problem. How do you know, how do you prevent the flow from going through? So I agree that for security, it's even a more difficult problem.
So I do like Vern's suggestion about crowdsourcing, but maybe this brings up a much more broader question for me. So I'll just give you some insights. So on a small campus, not that small, but a small campus, 2 campuses, so that we looked at the percentage of encrypted traffic we're seeing based solely on a port and protocol assumption. Okay?
Okay.
And 13% of the traffic was encrypted, was in that category just on that assumption, right?
Okay.
And a surprisingly a large percent of the traffic was based using octet streams. So you really had very little insight into the octet streams. So binary, so they were represented as octet streams on the wire. You couldn't use any of, so for example, bro or snort, the parson would just see that you couldn't rely on their protocol semantics to tell you what this really is, right? So that's a much bigger problem. So looking forward into the future, I mean, it seems that we're running into this problem where more and more of the traffic is becoming what we call opaque. You don't have that insight into. And so are we beating a dead horse? Does it make sense to go down the avenues that you're proposing?
So I think it is interesting that there are interesting problem of identifying binary protocols, or octet streams, as you say. It's an important problem, and a lot of techniques that have been used in the flow feature-based things could be enhanced to do the similar stuff at a packet payload level. So we need to start looking at those as well. So that is an interesting problem. And
even the flow-based stuff has a problem, right? Because you'll see a lot of connections that maybe start in one direction, start in one bucket as, you might call them clear text, you have insight into this, then you will see somewhere down the line a start TLS connection, and then so if you're not following that flow for the entirety, you might mislabel this, right? And it goes in the other, we've seen it in the other direction as well.
It goes back to threat model, though, or whatever, because if you're doing traffic engineering, okay, you can do engineering on it, it's an opaque plot,
Yeah.
I know what it is. If you're doing analysis of attacks and so forth, no, you're going to decrypt it, or you're going to application gateway it or something.
So from your point, would any of the crowdsourcing, in which threat model does this crowdsourcing avenue really help?
Well, it helps sorry. Say what?
Yeah, that's what I'm trying to get a sense of, under which threat model Vern thinks the crowdsourcing really helps.
It can help with the monitoring for attacks.
Yeah. Okay.
Shyam Mittur, Yahoo. I'm just thinking identifying an application doesn't really buy you much unless you know there's something bad about that application. Isn't it the patterns of activity from applications that's more useful? In other words, develop a signature or learn about a malicious pattern or 300 nodes inside your network talking to a botnet proxy.
yeah. So if you're talking from purely a security perspective, that is true. But even the fact that you are able to identify what applications are running in your network is a big first step. If you don't even know what applications are running, how can you start thinking about what are the defenses that you would have? So if you know that there are certain applications which are malicious and you want to prevent those applications from running, or you want to identify, say, which devices or users are using those applications, you need visibility into what applications are there, right? So if you're going after a different security threat, that you're looking after bots, of course, that is an important problem to solve. But this is also a very important security issue.
Okay. Final question.
All right, one more really quick question. Let's say we only talk about the content that you can actually analyze. How deep do you want to go in your analysis? I mean, are you interested in finding out, for example, that a certain URL was emailed to a certain number of recipients, maybe to identify people who engage in spam? I mean, how deep down do you want to go in the types of analysis that you do with this approach?
Ideally, the holy grail would be we understand everything from a network operator's perspective. We should understand everything that is going on. Who is communicating to whom, how they are doing it, what they are doing, what is their intent, but that requires you to understand the protocol, the application, the semantics of the application. So that is the holy grail, but I think that's a land which is far off, and it would take us a lot of time to reach there.